Good morning, good afternoon or good evening, depending upon where you live around the world. Here's a wee note. Apparently, when you make video recordings, it is better to have the microphone plugged in. That said, let's continue. I'd been quite a way through my video before I realised my mic wasn't plugged in, so all the good points I'd made I'm going to have to remake. This colourful dome is coloured in a way to highlight which struts are the same. Of course, these two are the same because they only have to rotate through the arc, and they are, with cuts different on each end, still the same as each other. Ditto here and here. Actually, these two here, so you've got 8 of these around the dome, identical, just with the cuts on different ends or different angles on each end. And of course the green, you've got the same thing, you've got 8 of those with the cuts on each end, etc. What it shows up is that there's quite a few different length struts in the dome, and that's one of the things with many of the dome's designs, that you try and get as few a different strut length as you're able to achieve. Now I think when we're building a dome such as this, where there has been some modifications to these two here in particular, it gets to the point where 1 or 2 more strut lengths, it's academic. Not ideal, but you just suck it up and you realise that the limitations or the output that we want may require those extra 1 or 2 strut lengths. I have shown on each strut the angle that's required to be achieved. It's in 0.1 of a degree, and the ability to obtain that, while difficult in itself, we at least need to know that it's closer to 81 degrees or it's close to 80 degrees. We don't want to fudge it. A half degree would be nice to be able to achieve the accuracy of half a degree, but if you're aiming for a particular measurement, you're more likely to hit it if you know what it is, rather than just be blindly going, oh, we'll round it up to 81 or we'll round it down to 80. It'd be better to aim for that slightly over, but you don't want to go towards 85. Here, if you went 81, no major drama. So trying to build in a slight fudge factor in your saw bench, drop saw, or your tilted router, it's better having the percentage known than it just being rounded up or down. You could say, well, anything over a quarter degree will round down. I really can't see there be much of an issue there. But knowing it, it's up to you to choose your method of accuracy, or your degree of accuracy that you're happy with. The 2 legs here, while they will be the same in the constructed dome, they are different because they relate to a different hub for the bottom. This tealy coloured has the hub, the green hub, which they are superimposed between the two over each other here at the moment, but the green hub is angled back to the centre of the dome, whereas the red one is level, it's in horizontal with the base plane of the height of the legs. Slightly different. The green is more technically correct, whereas the red, which would be horizontal, is, as you can see in this kind of mock-up here, much easier to build, therefore my preference. And there is no advantage on the bottom of the dome to have the hub angled. So if it's angled, it would have to have been 71 degrees. If it was to meet a level hub, 64.6. So there's quite a difference in that, but I've just highlighted it with the 2 colours to indicate that there is a difference. One of the things that you're going to find is the stresses on the different parts of the on the struts of the dome will be different. Oh my giddy aunt. At the top, they will generally be compressive, and in fact they will generally be compressive for vertical loads such as snow. But when you engage your thinking, you go, well, but not always will there be compressive loads. There'll be wind loads that can get underneath the dome and have that reverse parachute effect where it actually wants to lift the dome. So there'll be certain times when the stresses on the hubs will be both compressional and tensional. It's obvious. All joints can go through that that change in stress directions or loads. Why I'm bringing that up is that the point of the dome right at the bottom here has possibly got the highest loadings, because all the load that has been dissipated through the other struts are now all concentrating onto 2 points. So the method of attaching the hub to the struts has to have additional considerations given here, and it may well be that you may want to have tensional rods inside the timber, in which I'll touch on in another video, but you may want to make them rather sturdy, otherwise you get the idea that if loads are high enough, they may exceed whatever fixings that you have used to attach the struts and hubs. So basically what I'm saying is, don't simply rely on screws or bolts unless they are fixed in a mechanically robust and durable manner. One of the easiest ones is literally to weld a tab on here and a leg of metal coming up off of the hub welded, and then you can bolt or screw right through. That would be, I think, the easiest. Not always going to be the most elegant looking, and you've got to choose. My preference is to have an internal threaded rod that goes through an intersecting pipe or tube that the threaded rod can screw through, making it very, very difficult for it to pull out. As one of the points I was making in another video, flushing up the hub so that it doesn't create a high spot was a lot easier once I'd rotated these around the right axis, and I've dropped it down so that it touches the you could say the highest hub, because as you can see here, as the highest strut. So when the hub is being dropped down to it, you get this little discrepancy for the others, and that would just be something that you'd have to have and accept. But I think that's not too much, and it's not unpleasant to look at. The next thing we may want to look at is just where the points are going to be on the hub for you to drill, because it would be ideal the holes that you'll bolt through or screw through will be of the same distance down from the hub and located around the circumference in a easily achieved manner. The reason I'm saying this is that because there's a different angle for many of these struts, where you've got, say, 81 degrees here, but, or this is probably a better example, 72 degrees here and 82 degrees there and 77 degrees here, the distance down the cut here will be different from this one. Therefore, where we place our screw fixing may have to either alter on the timber, or the holes have to change. Now I know which one I'm voting for, and that's altering the placement of the bolt relative to the hub, because I prefer to see all the hub holes, say for instance 25 millimeters down all the way around, in their appropriate position, of course. But because we've got a very slight difference in the timber depth, so too will the distance down to that bolt line it will be. Now I know I'm not carrying enough clarity with that, but when you start to think of where you place the bolts, and they're only going to alter by 1 or 2 millimeters, it may well be that we decide to have a slightly larger hole, don't like that idea, in the hub to allow for those discrepancies, and then you can nib it up and secure the strut in its right place. My brain is, I can see a flashing light going off in my mind's eye. You've got to be careful, because the bolts are different from screws. The bolts have to be fixed in here into the strut, and they have to be far more accurate than, say, if you had holes in the hub and you screw through at whatever position you deem necessary. That doesn't carry with it enough accuracy to ensure the stresses are as neutral as possible in the hub, and you may inadvertently load up. I think there'd be a lot of redundancy here for the loadings, but not being an engineer, but having enough engineering information to give me concern, I try and keep the stresses as low as possible. And everything coming to a common point, yes, I'm going to leave that. There's enough concern that perhaps if you get to the point where you want to make a decent structure, you engage the services of a skilled registered engineer in your local authority. But I'm bringing up the points maybe more as a conversation piece than anything else, or a topic of concern. It's up to you. But I will make a video touching on that, and it may well be that a lot of the points can be countered or at least mitigated before you go and see the engineer. So, because I would suggest that not all engineers will have geodesic structure training. Well, I certainly don't, and it's been a bit of a discovery, a bit of a journey. Okay, I'm going to wander off because it is getting a bit long and a bit waffly, but the hub design itself, and specifically how you're going to attach them and where, may dictate the method of construction, or the accuracy issue about construction. Okie dokie, I'm going to go away, and I will see you in the next video. Okay, bye.